Hey all, good evening. How are you all? How are you all? Am I audible, right, guys? Tell me in a chat box quickly. Cool, guys. We'll start the session within 2 minutes. Okay. Hi. Once again. Yes. Once again, welcome to all of you guys here. This is Sham. Yes, today is the last day for the ray optics, guys. Okay. At any cost, today we have to finish this syllabus. Okay. Last topic of the syllabus is all about how to construct a telescope. And cool. टेलीस्कोप के बारे में बात करते हैं आज. दो टाइप के टेलीस्कोप होता है इधर. फर्स्ट वन वी आर गोइंग टू कंस्ट्रक्ट द टेलीस्कोप by using a lens. Okay. Second one, actually lens is not an advantage, correct ना, because two loss होता है. First one is intensity loss होता है. Second one is that cost ज्यादा होता है, बहुत cost होता है. It will be okay. That's why we are going to construct another one telescope by using the mirror. It's called the Newtonian Telescope. Okay, these are the two kinds of telescopes which we are going to discuss in today's class. Okay, cool. Before starting that class, let us take a quick recall what we discussed in our previous class. Okay, in previous class we discussed about the microscope. Correct now? Microscope mein two kinds we discuss now. First one is simple microscope and second one is that compound microscope. Right? In simple microscope क्या था actually? In simple microscope means only one lens we are going to use. करना है simple. आप करता है ना मैग्नीफाइंग लेंस को फोल्ड करके छोटे ऑब्जेक्ट में देखता है ना. You want to visualize the small object by using a magnifying lens, right? That is a simple microscope. That's it. Okay. And then compound microscope क्या होता है? More than one lens we are using here. That is the compound microscope. In both the case we studied here or we calculated the only one thing, that is a magnification. Means object, we are going to find out the image size by object size. Comparison कर दिया मैंने. Correct now? That is called the magnification of a lens. Here in simple microscope the magnification obtained to be कितना आया था? M is equal to capital D upon F. Correct now? M is equal to 1 plus D divided by F. I told you this is an eyepiece. Correct now? That's why we can write this one as a magnifying lens, magnification for the eye lens also. No problem. Clear? In a similar way, we find out the compound lens, compound microscope also. In compound microscope, क्या किया था हम? Actually, in first simple microscope में, we created a virtual image directly. Where we kept the object we are going to keep in between a optic center and as well as the principal focus due to forming a virtual image. But in the sense of compound microscope, we can't do like that, because if you do like that means virtual image also creating in this side only. Correct now? And again that image will be forming to this side means, right, that time the intensity of light will be decreases and we can't able to magnify the image. If the image will be magnified also means we are seeing from this point, no, right hand side, image will not be clarified, means clear image will not be obtained, right? For that reason क्या करते हैं हम इधर, we are going to create a real image, and that real image should be an object for the second lens. This eye lens को object के तरह behave करना है, correct ना? But the final image should be erected one time again. This is a real image, and then that erected image will be formed here greater than the first image. Here we find out the magnification for the two lens also, objective lens and as well as eye lens, correct? And finally we find out the magnification of the total one. Total magnification को कितना आया था? M is equal to m naught. M naught is nothing but m naught means or else mo. Mo is nothing but magnification for objective lens. This is the objective lens, correct now? And then me I told this is a magnification for eye lens, right? It's a product. Total magnification क्या होता है? M is equal to mo into me. Already magnification of eye lens we calculated in the first derivation, that is 1 plus d by f, correct now? We need to find out here magnification of objective lens. Objective lens के लिए क्या आ गया था हमको? a dash b dash by ab. It is nothing but size of an object by size of an image. That's it. Okay, into 1 plus d by f. Clear है ना? Up to this point, is it clear? Let me know through the chat box quickly. We can substitute the value of m also here, m naught also. It is nothing but image size by object size. This is with respect to the magnifying lens, objective lens, that is m v naught u naught into 1 plus d by f. What is here d? D is nothing but this one, the distance of the final image forming from the eye lens. Clear? We can call this one as a least distinct division also, right? This value will be around 25 centimeter. Cool. Okay, well, after this, okay, if you know this much means next thing we are going to discuss about further. Before that one, guys, I have few questions. Okay, first question is that here in all optical instrument we use, which is the correct option among the four? In all the optical instrument we use ray optics, wave optics, physical optics, none of the above. Give your valuable answer here quickly. भगवान ये कहाँ है तू? What is the answer? Yes, correct. The correct answer for this question will be ray optics. Correct now? With the ray only we are dealing all the answers. Cool. Okay, it is good. Next thing is that here, next one more question. The lens used for correcting the myopia is, which lens you are going to suggest for the correcting the myopia defect? Myopia is nothing but short sightedness. Correct now? You can visualize the object which are present very near to your eye, right? Far distance objects को आपके लिए दिखना मुश्किल हो रहा है. Okay, this is the myopia defect. Which lens you are going to suggest? Let me know quickly. This is your eye, आपका eye lens. Okay, short sight and short sight में means around up to a certain distance, d distance. इधर एक object है means you can clearly visualize this. So you can clearly visualize this one. correct now, means the ray of light which are falling here, no, it will be converged at the retina point. There is no problem, correct now. If the object is moving away from the near sight means ये lens को क्या करना पड़ता है, actually it has to decrease its power, correct now. Power has to be decreased. Power has to be decreased means it is nothing but it increases its means it will be ciliary methods, it will be increases the aperture, correct now. If they are not increases means क्या होता है, if the object is moving far means these refracted rays है ना, actually they are not converging at the retina, instead of they are converging back the retina here, correct now. Here they will form. Now we need to bring this image to this position means एक convert नहीं हो रहा है ना, right? What I am saying, is this myopia? Is this myopia? This will become a metropia now, hypermetropia. Nobody tell me. Good, no worries. Okay. Power नहीं होता, क्या होता है, before the eye lens they are going to converge here. Image will be formed here, means इसको extend नहीं हो रहा है, इसको ये इमेज को इधर शिफ्ट करने के लिए क्या करना है, एक कन्वर्जिंग ज्यादा हो रहा है कम करना है, मींस ऑपोजिट वाला लेंस को लगाना पड़ता है. We need to introduce one opposite kind of lens. It's a convex lens, our eye. Right now, we need to introduce here concave lens. When you are going to introduce the concave lens, now this light rays first they will diverge both the side, and then will be converged at this point. Means which kind of lens you need to use here? Yes, concave lens. Cool. Hope it is understood. Let me know quickly. Okay, right. We'll move towards next thing is that compound microscope. A compound microscope क्या होता है? Compound microscope. Yesterday we discussed this one, no? Compound microscope वाला. Yes, right. Already we discussed. Why I took again? Yes, compound microscope already discussed. Okay. Astronomical telescope we need to discuss. Okay, astronomical telescope. Why we are going to use the astronomical telescope? First point is why we need to use the astronomical telescope. Yes, because to see the celestial objects which are present in our sky, means in a universe, we are using the astronomical telescope. Okay, those are very far away from our Earth. No, we can visualize those objects by using the astronomical telescope. कैसे visualize करते हैं देखते हैं. Here we are using the two lenses. First one is object lens. I'm going to call this one as LO. Second one eye lens, means eyepiece. होता ना वो second one. If first lens है ना, it should be a larger aperture. क्या है? Large aperture होना चाहिए. Right? Why means if you're collecting a huge number of light rays which are falling on it, means more bright images will be formed. For that reason, we are taking object lens as an very larger aperture. Right? We know that if you're going to take a smaller aperture lens means क्या होता है उधर? Less number of light rays will be fall on it. If the less number of light rays will be fall on it means less amount of intensity will be formed. Image का. If you want to take the larger aperture means क्या होता है? Huge number of light rays will be fall on it. Collectively, all the number of light rays which are intensity will be increases. If intensity is increases means bright image will be formed. Right? What I'm saying. That's why we need to take here large aperture lens for the objective lens. Let us take, okay. And then next thing is that just imagine source is very far away here, okay. From that source, light rays are incidenting on this first aperture with some an angle theta, okay, not parallelly. I'm going to take it an angle. I say thank God. The light rays which are coming from the infinite distance are almost parallel to each other. Don't forget these are things. Right now, parallel things. Here dots are so there no. I'm going to call this one as a principal focus for the objective lens. This is also principal focus for the objective lens either side. And the eye lens is there no. For eye lens also first two things we are going to discuss here. First thing is that normal adjustment, guys. एक कौन सा है? Normal adjustment. ये नॉर्मल एडजस्टमेंट में क्या होता है फर्स्ट बता दूंगा तो आपको, ओके. हियर एफ नॉट इज द प्रिंसिपल फोकस फॉर द ऑब्जेक्टिव लेंस. हियर फॉर द सेकंड लेंस है ना, इसको भी प्रिंसिपल फोकस होता है ना, वो कोइंसाइड होता है सेम पोजीशन में एफ पी. सिमिलर वे दिस साइड आल्सो एफ पी. करेक्ट. at this position only, in this same plane only, this images, the image of the object will be formed. कैसे देखो इधर, if I'm going to extend this one means the ray of light which is incidenting along the optic center without deviation it will become correct. Now if the ray which is incidenting on the aperture means it will be refract and it will become to this point. Just a minute. Here I don't have a scale, that's why the rays which are coming very bad. While writing, you people please use the scales, okay. Okay, this ray will be come to here. Now the first image of the source of object will be formed here. देखो कितना बड़ा हो गया, correct ना. I will write this one in a green color. choose करते हैं, ये तो green है. इधर I will call this one as an A B. Right here it's an inverted real image बन गया. Inverted real image कोई प्रॉब्लम तो नहीं है. Actually invert real image for astronomical objects को नहीं होता है, because asteroids almost all the particles they are in spherical in shape, correct ना. Spherical in shape means उल्टा सीधा होता तो प्रॉब्लम तो नहीं है ना, कोई प्रॉब्लम. This is what the image which is formed due to the objective lens, the collectively rays which are coming from the that celestial object in a sky. You may treat this one as a star also. Okay, now this is what the image is formed here. Now you may have an idea why I took the light rays which are falling on the objective lens in an angle, correct now. When I'm taking with an angle, that time only I can take on diminished object here, diminished image. This image will be behave as an object for the eye lens, correct now. If I'm taking bright image means parallel image which are falling on this one means like this. This is the aperture which are falling very parallel means very small minute amount of image will be formed. इसको रिजॉल्व करना बहुत मुश्किल होता था, इसलिए क्या कर दिया मैंने, I took some angle theta. Clear है ना. हाँ, okay. Now this image behave as an object for the second lens. Second lens को ये image से object होता तो again the light rays will fall on the second lens. No, from this object से light will be falling parallel to the principal axis means it will be passing through the principal focus, correct now. Second one, this is the optic center 2, this is the optic center 1. Okay, if any ray which is passing through the optic center means without deviation it will be good. Look at here, these two light rays which are parallelly going, correct now. If you are going to watch these two rays means they are not intersect or converge in this side, okay. If you are watching these two rays by extending backward means image will be formed at इनफाइनाइट डिस्टेंस, पता है ना, राइट? दिस इज द extended reflected rays. This rays will be meet at infinity. We are going to call it general. Correct? Here it will be forms virtual and erratic image. Clear है ना? Either from the object distance है ना? This object distance. This is the object distance. I'm going to call this one as an UE because this is an object for the eye lens. That's why. Okay, and then one more thing, from the first object to principal focus, the distance is called focal length of the objective lens. Second one we're going to call focal length for the eye lens. Now if you want to write the magnification, means how to write the magnification, we need to write in terms of angle. Yesterday only I told you, correct now? In terms of angle means देखो इधर, सुनो ना, either this is alpha, correct, to the principal axis, light ray which are incidenting at an angle alpha. The same angle will I'm going to take from this point alpha, right? And for image which is created here from the second lens, I'm going to call this one as an beta. Cool. Now देखो इधर, सुनो मैग्निफिकेशन क्या होता है? Magnification is equal to, yesterday I told, in angle beta by alpha we will write, correct ना? बीटा को क्या लिखते हैं हम? tan beta by tan alpha, करेक्ट ना? ओके, tan बीटा क्या होता है? देखो इधर एक बार, tan बीटा वैल्यू क्या है इधर? बीटा ना, tan बीटा मीन्स ऑपोजिट साइड बाय adjacent साइड. ऑपोजिट साइड क्या है इधर? हाइट ऑफ द इमेज, करेक्ट ना? हाइट ऑफ द इमेज का कैसे दिखता है आपको इधर? ए बी डिवाइडेड बाय adjacent side to from the principal focus to optic center, it will nothing but O to A. Clear? First thing. Okay. Second thing, tan alpha is there. Tan alpha is equal to alpha angle subtended by the objective lens. क्या होता है? Opposite side again AB, adjacent side होता है O1 to A, correct ना? Again AB divided by O1 to A. Substitute these two values in the magnification equation. देखो इधर, magnification m क्या होता है? Then tan beta means AB upon O2A into second one. In denominator I want to write, that's why I will write here AB upon O1A. Cool. AB मर गया, remaining क्या हो रहा है मेरे साथ? Yes, O1A divided by O2A. O1 to A is the distance, is nothing but focal length of the objective lens. O2 to A is nothing but focal length of the eye lens. Substitute these two values here, then it will become, क्या होता है इधर? O1 to A is nothing but focal length of the objective lens divided by focal length of the eye lens. Correct? Cool. Everything is okay, but one thing is missing here. क्या है missing thing? बताते हैं क्या आप? क्या मिस कर दिया मैंने इधर? बता दो. Tell me that what I missed here. Thing which I missed here. Yes, that is what sign. No, for the first focal length, it will be in this direction, in the light traveling direction. That's why positive. For the eye lens focal length होता है ना, it is we have to take opposite for the incident light direction. Incident light तो ये direction में है, correct ना? Opposite side we need to move, then it will become minus. Hence magnification obtained to be f0 divided by fe minus fe. This is what the magnification for the normal condition. Normal condition के लिए magnification ये होता है. Clear? Hope it is clear. Let me know quickly. However, the value of beta is greater than the alpha. Okay, that's why the image which is forming here, no, the image will be more in size than the objective. Hmm? कोई problem. Okay, if it is clear means next thing is to be one more thing is there. Actually, it's an telescope. Telescope means आपको पता है एक pipe होता है. Pipe means some length it is there. In that length, eyepiece को आप क्या करता है? Move करता है. Correct now you can move, but the objective lens which will be fixed one. Means here we need to find out the tube length. Tube length is nothing but tube light का length है क्या? आपके घर में होता है ना? Is it right? No. Tube length is nothing but guys here. What will be the length between a two lenses? The lenses का length क्या होता है? That is called the tube length. We will generally represent this one with a L. This is very important for the calculation. What is the tube length? According to them, might be say general formula I will write. According to them, they will be asked in terms of objective. Object distance, image distance also sometimes. Okay, be aware of it. Cool. Okay, tube length क्या होता है इधर? Tube length. Tube length L is equal to total length between them. It is nothing but here F4 objective focal length plus I focal length. Correct है ना? Is it right? खत्म. ये तो नॉर्मल एडजस्टमेंट का कहानी था अब तक. नाउ वन मोर इज देयर. कौन सा है? स्पेशल एडजस्टमेंट. क्यों स्पेशल एडजस्टमेंट? यस, आई विल टेल यू. बिकॉज इधर तो इमेज बन रहा है इनफाइनाइट. इफ इट इज फॉर्मिंग एट इनफाइनाइट डिस्टेंस मींस हाउ इट इज पॉसिबल टू सी द इमेज, right? It is very difficult to analyze the image. For that reason we need to form the image with the least distinct vision of our eye. Means least distance of vision कितना distance होता है? 25 centimeter होता है ना? We can clearly analyze the object no with a distance 25 centimeter. That is what the least distinct vision of the eye. Means we need to form the image at a distance d. Means from this lens to at a distance d में image create करना. If you want to create the image like that means what we need to do means here eye lens है ना, I already told you it's a lens we can easily move over this principal axis. Okay, by adjusting this one we need to find out the means we need to focus the image at 25 centimeter. Clear? Let us check how to find out. Okay. Yes. देखो इधर. This is the principal focus of the objective lens, which is eye lens. Correct now? Again, this is the principle of focus of the objective lens. Here देखो, दोनों क्या हुआ था? First normal adjustment में coincide हो रहा था. Now what I did actually, just I'm going to move the eye lens towards the object lens. Now what will be happen actually? Now the first image what it is created, no, it will form at this FO principal focus में form होता है, but this object which will be formed in between optic center and as well as the principal focus of the eye lens. Eye lens के इन दोनों बीच में form होता है ना. This is the objective lens का 1 and 2. Correct ना? At this condition क्या होता है? Virtual image will be created. Along with this virtual image, it will be formed very near to our eyesight. Correct now? That is what least distinct vision of our eye. In that form, let us draw the diagram first. Okay, first diagram तो इधर है. Ray of light which is passing through the optic center, it will become here. Correct now? Second parallel ray which is incident. These are all incidenting at an angle theta or else alpha. Okay, it will be refract and it will be concentrate at this point. If any ray of light which is coming at this point means this is the ray of light which is incidenting here. Finally, the image will be formed at principal focus with the enlarged manner. This is A B. Correct है ना? Now we need to form the image. No, first, if any ray of light which is incidenting parallel to the principal focus on the curvature aperture, it will be passed through the principal focus like this. If any ray of light which is passing through the optic center, then it will be passing like this. Because these two refracted rays actually they are going diverging like this. Correct now? They never meet each other at any time. Now what we need to do? Just extend these two refracted rays backward direction. Correct ना? Backward direction के लिए extend करो. ऐसे इसको ऐसे extend करने से इधर image बनता है. Correct ना? This is what the point. Now if you want to write the ray image बहुत मुश्किल हो रहा है यार इधर ड्राइंग करने के लिए. देखो, this is what the final image which is created. This is B dash, this is A dash. देखो इधर इतना बड़ा इमेज बन गया है ना, इतना बड़ा इमेज बन गया. ऑब्जेक्ट तो इनफिनिट डिस्टेंस में छोटा है. फर्स्ट इमेज तो ये भी है, सेकेंड इमेज बन गया ये डैश बी डैश बहुत बड़ा. राइट, वी कैन इजीली विजुअलाइज दिस इमेज फ्रॉम दिस पोजीशन. क्लियर है ना? वर्चुअल इमेज बन गया, काम खत्म नहीं हुआ. नाउ द थिंग इज दैट वी नीड टू फाइंड आउट द मैग्निफिकेशन. मैग्निफिकेशन के अलावा कुछ भी नहीं तो फाइंड आउट करते हैं हम. मैग्निफिकेशन ही फाइंड आउट करना पड़ता है. ओके, मैग्निफिकेशन. हाउ टू फाइंड आउट द मैग्निफिकेशन? अगेन वी नीड टू टेक द एंगल्स. एंगल्स किधर किधर बन रहा है? इधर देखो, ऑब्जेक्ट से इधर अल्फा, इमेज से बीटा. क्लियर है ना ये? चेक वंस. यस राइट. एंड देन ऑब्जेक्ट से आई लेंस तक है ना डिस्टेंस, विल कॉल दिस वन UE, मींस ऑब्जेक्टिव लेंस से ऑब्जेक्ट डिस्टेंस. ओके, फ्रॉम दिस पॉइंट टू लेंस the distance is there. No, this is the least distinct vision of our eye. V, this is the image distance है, but it's a least distinct vision of an eye. First you calculate the magnification for the lens. Magnification कैसे calculate करता है पता है ना? कैसे कैसे कैसे? First we need to take the objective lens. Magnification. ऑब्जेक्टिव लेंस के लिए क्या होता है इधर? अगेन बीटा बाय अल्फा. बीटा बाय अल्फा मींस अगेन tan बीटा बाय tan अल्फा. विल टेक ज्योमेट्री. tan बीटा क्या होता है? बीटा इधर है. ओके, फ्रॉम दिस पॉइंट बीटा क्या होता है? ऑपोजिट साइड ये बी डिवाइडेड बाय, आई विल राइट हियर गाइस, लुक एट केयरफुली. tan बीटा इज इक्वल टू AB by O2A. करेक्ट ना? सिमिलरली tan अल्फा क्या होता है? दैट इज आल्सो AB डिवाइडेड बाय O1A. AB डिवाइडेड बाय O1 ये होता है. इफ यू सब्स्टिट्यूट दिस टू वैल्यूज इन दैट इक्वेशन मींस व्हाट यू विल गेट एक्चुअली मैग्निफिकेशन इज इक्वल टू tan बीटा मींस AB by O2 into A into again AB over O1 into A. AB cancel, remaining thing will be O1A divided by O2A. Correct ना? O1A क्या है? O1 to A, it is nothing but focal length of the objective lens. Focal length of the objective lens, FO. Right here, FO divided by O2 to A. O2 to A is there? No, this is what the object distance. It is nothing but object distance UE, but we need to write here negative sign because opposite to the incident light direction. No, that's why. Then magnification value कैसा होता है? F0 divided by UE. इधर ही खत्म होता है ना? नहीं, एक्चुअली मैग्निफिकेशन मींस we need to write the magnification for the two lens. This is only one lens हो गया, और एक लेंस को कैसे कैलकुलेट करना है? by using lens makers formula, right ना? lens makers formula क्या था? 1 by f is equal to 1 by v minus 1 by u, right? इधर f means here it is nothing but I lens, e image बन रहा है I lens से, that's why v is nothing but image of the I lens, objective lens u, correct ना? Okay, what will be the value of v, image of the I lens will be, it is nothing but d, negative d expression d, correct ना? Substitute these values and find out the value of here 1 by ue. Why means if you find out the value of 1 by ue means you can easily substitute here magnification. Equation number 1 में substitute करने से magnification मिल जाता है. That's why then 1 by ue, if you want to take left hand side, then it will become 1 by ve minus 1 by fe. Correct now? Or else you may write like this also. There is no problem. I will write now. Okay. 1 by fe. 1 by v left hand side लेने से क्या होता है? Minus 1 by ve. Clear है ना? ये तो है माइनस इधर से. Cool. नेक्स्ट क्या होता है? नेक्स्ट पॉइंट v का वैल्यू माइनस d है, right? Substitute this value in this equation, then you will get minus 1 by ue is equal to 1 by fe plus 1 by d. माइनस इंटू माइनस प्लस होता है ना? खत्म, नाटक बंद. क्लियर? राइट व्हाट आई एम सेइंग? Cool. Then देखो 1 by fe is there, no? I need some calculation for that's why I will take 1 by fe as an common. If you take 1 by fe as an common outside means 1 by fe, then what is the remaining thing here? 1 plus इधर क्या होता है? fe upon d होता है. This is nothing but minus 1 by ue. Correct है ना? Right what I'm saying? Now we got the value of 1 by ue. In magnification, it is nothing but 1 by ue is there here. Substitute this value in this equation number 1. Substitute. While if you want to substitute here, no, देखो इधर equation 1 में डालने से magnification value will be f naught minus into minus plus होता है, correct ना? Then divided by fe into 1 plus fe divided by d होता है. Clear what I am saying? This is what the magnification for the astronomical telescope. Astronomical telescope के लिए magnification क्या होता है? f naught by f into 1 plus f by d. Clear? Here f naught refers to what it refers? F naught focal length of objective lens. Objective lens. Fe refers to eye lens. Focal length of the eye lens. Clear ना? D क्या रेफर करता है? It's a least distinct vision of our eye. D वैल्यू क्या होता है? 25 सेंटीमीटर बोल दिया ना मैंने, ये होता है. Cool. Well and final settled. And few disadvantages also there from this astronomical telescope. क्या disadvantages होता है? First disadvantage. First I will take advantages. Advantages क्या है ना? If you take the more bigger aperture of this convex lens means more number of light rays will be fall on. If more number of light rays will be fall on means it's a bright images will be formed, magnified bright image, highly magnified. Right? This is only one first advantage I will take. And disadvantages क्या है ना? If you want to find out, if you want to prepare the big aperture lens means cost तो बहुत ज़्यादा होगा. It's very highly cost. Second most thing is that difficulty while preparing this lens. क्या होता है, the refractive index of this material medium should be uniform toward all the points. Correct ना? If this uniformity will be not constant, means the image which is forming by this mirror lens है ना, it will be distinct. Means दो image भी बन सकता है sometimes. It, it will be not uniform because the after refraction rays will be go different places. No, that's why it is very difficult to form the refractive index of that medium in a uniformity. That's why in the market, if you want to purchase any lens, means the cost of lens will be very high. Yeah, this is the main reason behind this. And in a word means as we collected the data, no, in UAE only, it has a bigger aperture lens is there, whose diameter is around 1 or 2 centimeters. Okay, it is one of the biggest lens which is present in our universe according to statistics. Cool. It is enough. Up this point is astronomical telescope. Hope you guys understood this concept well. And next thing is that yes, Newtonian telescope. EMP telescope, cheap and best. You can also prepare this one in your home. How to prepare this one? I will tell you. It's a simple thing. इधर है ना, second image में देखो. This is one of the pipe, PUC pipe with some aperture, bigger aperture. Okay, इसके inside में at this bottom part we need to keep one concave mirror. कौन सा mirror? Concave mirror. देखो इधर first में फिगर में explain किया, concave mirror को इधर रखा हुआ है. करेक्ट है ना? ये ओपन विंडो है ना, ये ओपन विंडो. This open window we need to focus towards this star. Star means from which source you want to receive the light rays. No, towards that point you need to focus this one. Open window. Light will be fall on the mirror which you kept at this bottom. Mirror है इधर, इधर है ना, देखो इधर. Light will be entering through this tube and they are falling on the concave mirror. Right? I want to know one thing here. Concave mirror क्या करता है light rays को? If the light rays which are falling on the concave mirror means what will be happen? Let me know quickly in the chat box. What will be happen when concave mirror के ऊपर light rays will be fallen? Yes, good. When light rays will be fall on the concave mirror means it will convert the light rays. Right now, it will convert the light rays. That's why we call concave mirror as a converging mirror. क्या हो गया यार? Yes, good. ठीक है, okay. देखो इधर, इसके ऊपर light rays fall. They are reflected back. Means they are converging. Right now, they are converging actually this point. In this point, actually, really they converge. Right now, don't take about this flat mirror at this point. Okay, they are converging here. Here, convergence means the real image will be formed. Real image will form. If the real image will be formed here means it will be a bright and short and diminished image. Okay, that kind of image you can't able to see by your means थोड़ा resolve करना है ना हमको, right? Yes. Now क्या करना है इधर? What I will do? No. And one more. एक मैंने okay. One more thing I want to tell you that एक concave mirror है ना, एक concave mirror का focal length होता है ना, it should be very large focal length होना चाहिए. Okay, the image which is forming here, no, it is all about focal length. This is what the focal length of this concave. Now I will keep a mirror, short mirror, at an angle 45 degree to the principal axis. The principal axis के 45 degree में एक mirror को रखता हूँ. The mirror which should be very short, बहुत short होना चाहिए. If the light rays which are converging on this mirror, no, they all fall here and reflect back. actually this image है ना, this image will be acting like an virtual object because it is forming due to incident, extended incident ray here. Correct now, when you keep this mirror, no, it will become a virtual object. इसका real image किधर बनता है? Perpendicular to this mirror here. Correct now, if the mirror is like that means perpendicular to the mirror, here the image will be formed. Means reflected rays होता है इधर, इधर image form होता है. Right now, this image which is formed by this mirror, no, it is now virtual image. Now we can visualize this image by using the magnifying lens. Eye lens के साथ we can visualize it a bigger. Clear? This is what the construction of making astronomical telescope. That is a Newtonian telescope. Correct है ना? Okay. Either magnification value also we need to find out. Magnification होता है इधर focal length of the objective mirror divided by focal length of the eye lens. This is what the magnification formula to find out here. Here f naught refers to focal length of objective mirror. Okay, fe refers to focal length of eye piece. Clear enough? Okay, I hope you understood this one in a well way. Clear? This is all about concept. We'll solve one numerical. Yeah, look at here. This is an outstanding image. This is actually this is a working model of the Newtonian telescope. Or else we can call this one as a reflecting type telescope also. Look at here. At the depth we kept a mirror. Correct now? In depth a mirror we keep this, and the ray of light which are incidenting on this mirror, no, they are reflected and focus at this point. What I am shading now with yellow color on the mirror, which should be very small. In the same side, you need to keep on eye lens. Right now, ये इधर image बन रहा है ना, आप वो image को enlarge करके देख सकते हैं. Clear? This is what the concept of a Newtonian telescope. Why we are, it's a best advantages. You can also create this one in your home. Okay, advantages क्या है means it is very cheap in price. Price wise तो बहुत cheap है. With a simple amount you can construct this Newtonian telescope. Second point है almost all reflection से bright image form होता है. कौन सा image? Bright. Because when light enters from one medium to another medium, best example is a concave mirror, concave lens or convex lens. Light traveling in a medium, its speed decreases, intensity also decreases. But due to the mirror, intensity will not decrease. Almost all. It's a reflected mirror, no. Almost maximum percentage will be reflect from the mirror. Intensity will be maximum motor. That's why from these two conditions, I can say the best and cheap for constructing the telescope. Clear enough? Okay. Then yes, we'll solve a numerical problem here and we'll end up the session. Okay. Here the question is that an astronomical telescope has a magnifying power 10. Means the given magnification of the astronomical telescope 10. In normal adjustment, the distance between an objective and eyepiece is objective and as well as eyepiece का distance क्या है ना वो बता दिया है इधर. That is the least distance of vision. RS जो आई लेंस के बीच में जगह होता है ना उसका distance है 22 centimeter. Right now we need to calculate the focal length of the objective lens. Means focal length of the objective lens calculate. Listen, सुनो क्या है ना, I will explain the brief way. Astronomical telescope है, one lens is a bigger one another lens which we are going to take here, very smaller aperture. Clear enough? Now the thing is that here first normal condition they given, normal adjustment. Normal adjustment means ये दोनों लेंस के लिए इक्वी डिस्टेंस में क्या होता है, वो इमेज क्रिएट होता है. मींस फर्स्ट ऑब्जेक्टिव लेंस क्या है ना, उसका फोकल लेंथ में सेकंड आई लेंस है ना, आई लेंस का फोकल लेंथ, इन दिस प्लेस द इमेज विल बी फॉर्म. करेक्ट? In this condition they given focal length of the objective lens we need to calculate. What is that focal length of the objective lens? Here the image बन रहा है ना, उसका magnification value दे दिया है 10 and the least distinct vision of our eye, the image where it is forming, virtual image here, it is also they given d value 22 centimeter. By using this condition or criteria or parameters, we need to find out the focal length of the object. Simple तो है ना, 2 मिनट टाइम देता हूँ. ओके, कैलकुलेट दिस वन वेरी सून. Good. 2 minutes of time. Okay, did you got the answer, guys? Yes, fine. We'll solve this one. Okay, then it give the idea about how to solve this one. Okay, focal length of the lens calculate करना है, objective lens को. Magnification बोल दिया है. क्या होता है formula इधर? Magnification will be equal to focal length of the object divided by focal length of the eye lens. ये पता है ना आपको? I hope it is no. Correct? Yes, right. Correct. And one more thing. Okay. Now you substitute these values here. Substitute the values. Magnification will be equal to, actually we need to calculate this value f0. F0 will be equal to fe to either multiply focal length of the eye lens. But now magnification value already they given. Then f0 will be equal to 10 times the fe होता है. We got an equation. Great. Right now fe value, now f0 का value 10 into fe होगा. Now we need to calculate the value of fe. Fe means here it is nothing but focal length of the eye lens. Just a minute, guys. Fe, how to calculate the value of fe? They given one more value also, d. D is nothing but the distance between the two lenses. Right now, that is called the tube length also. Right? Tube length क्या होता है इधर? Actually, d value will be equal to focal length of the objective lens plus focal length of the eye lens. Clear enough? Now, substitute the value of f0 here. f0 का value 10 fe ना? Substitute here. D is equal to 10 fe plus fe होता है. Then d value will be equal to 11 fe होता है. Right? 11 fe. fe का value तो पता करना है ना हमको इधर. Right? We don't know value of fe also, but d का value पता है 22 centimeter. Substitute here. Then look at here. I will solve here in this one. D means 22 divided by fe 11 comes to here. Then it will be equal to fe. fe का value कितना हो गया? Fe is equal to 11 1 11 2 टेबल 2 सेंटीमीटर हो गया. Substitute this Fe value in this equation. इधर इधर सब्स्टिट्यूट करो बच्चों. इधर सब्स्टिट्यूट करने से क्या होता है, focal length of the object ends will be equal to 10 times the Fe, means it is nothing but 2 centimeter. Then focal length of the object in length will be equal to 20 centimeter. है ना, आसान से कैलकुलेट कर दिया हम, सिंपल सा. करेक्ट? Is there any doubt? Let me know through the chat box quickly. Good. If you don't have a doubt, means guys, I will give you a question as a homework. Okay, take this one as a homework. Okay, this is a homework question. Try to solve this in home, and I will ask the answer in the next class for this question definitely. Okay, and moreover, this is all about optics. Okay, optics का सभी के सभी concept complete हो गए हम. Okay, thank you for all being here. And tomorrow onwards, we are going to start a new chapter, that is wave optics. Okay, wave optics and ray optics. I already told you these are the very high weightage chapters. Okay, and be careful about these two chapters. Okay, okay, maximum from tomorrow onwards, we are going to start wave optics. Cool. Okay, then if you don't have any doubts, means you can leave the session. Okay, we'll see you in a tomorrow class. Until then, take care. Bye bye.